guys, welcome back to my channels. In today's video, we're going to talk about how I generate a graph based on the time taken for the hot air balloon to stay afloat versus the weight of the passenger. As I mentioned in a previous video, the time taken for the hot air balloon to stay afloat with no passenger was 60 seconds, and with 5 grams of passenger, the time taken was 30 seconds. I created a table and generated a graph, and as you guys can see, the graph shows an inverse relationship. It has a negative slope, meaning as the weight increases, the time taken to stay afloat decreases. This behavior can be explained by buoyancy, thrust law, and second law of thermodynamics. Buoyancy is the upward force that a fluid exerts on an object in it. In the case of hot air balloon, the buoyant force is generated by the hot air inside the balloon being less dense than the cooler air outside. The balloon rises because the buoyant force is greater than the weight of the balloon and its passenger. Charles' law states that the volume of a gas is directly proportional to its temperature, assuming the pressure is constant. Heating the air inside the balloon causes it to expand, decreasing its density and increasing the buoyant force. However, as more weight is added to the balloon, more buoyant forces is needed to keep it afloat. This is why the time taken for the balloon to stay afloat decreases as the weight increases. The second law of thermodynamics states that the total entropy or disorder of an isolated system can never decrease over time. In practical terms, for our hot air balloon, this means that the hot air inside the balloon will eventually lose heat to the cooler surrounding air. As the air inside the balloon cools, it becomes denser, reducing the buoyant force. This heat transfer process contributes to the decrease in float time as the balloon lift diminish over time, especially as additional weight is added. Understanding this principle helps us grasp why adding weight to the hot air balloon reduces its float time and highlight the delicate balance between lift and weight in maintaining flight. It also underscores the inevitable tendency of the system to lose usable energy. In this case, the heat that keeps the balloon aloft. Okay, that's all for today's videos. Bye bye.